Hi everyone. We're back to work through the last problem of this week's practice set, an introduction to solving trig equations. So in this problem we're asked to solve sine of x plus pi sixth equals 1/2 for a domain of negative 2 pi to positive 2 pi. So similar to the last problem, we have something happening to the sine. There's some, this would be a horizontal translation actually is what's happening to this function if we want to think about it in terms of that. So we're going to approach this similar to how we approached the last problem, and I don't want to worry about this expression that the sine is being taken of right now. So I'm going to let u equal x plus pi sixths. So whenever a sine is being taken of some value that isn't just the variable we're looking for, we're going to substitute that for a second variable. So what this does when we rewrite it, sine instead of x plus pi sixths, we're replacing u with that value, is 1/2. So what we want to find here is when sine is equal to 1/2 between negative 2 pi and positive 2 pi. Well, we've done this problem already. We've seen it a lot if we actually start thinking about it. Based on a unit circle, if we want to go from 0 to 2 pi, and we can look at that unit circle. I might have some mess on here already. It looks like we've got them stated. But similarly, we can go through and say, well, sine is equal to 1/2 at those values we just saw. So the sine is equal to 1/2. The y value of this ordered pair is 1/2 at pi sixths and 5 pi sixths. So our u values, the solution to this, are pi sixths and 5 pi sixths. So that is for x values between 0 and 2 pi. So now we need to consider this negative 2 pi. And when we consider the negative 2 pi, just a quick reminder, here's our unit circle. If I have some value on my unit circle right here, let's say this is pi sixths, and I want to open up the world of the negative radians here, negative 2 pi is the value I'm interested in. What I can do is I can go in the opposite direction as we normally go, which is clockwise around the unit circle, one full revolution, or that's 2 pi. So if I want to move in the opposite way, I subtract 2 pi from this. So we have other values here between negative 2 pi and 0 that we take the values we found initially, pi sixths, and we take away 2 pi, or we go one revolution in a clockwise manner. Similarly, the next value is 5 pi sixths minus 2 pi. And if we do some quick calculations here, this is pi sixths minus 12 pi sixths, and this value is 5 pi sixths minus 12 pi sixths, because that's equivalent to 2 pi. So the other two values that fall outside of our traditional domain of 0 to 2 pi, but fall within negative 2 pi to 0, are going to be negative 11 pi sixths and negative 7 pi sixths. So if we write all of these values out, those are the u values we can find. So let's go to black, a new color, because we're doing something a little different here. So we're saying u can equal negative 11 pi sixths, and u can equal negative 7 pi sixths, and u can equal pi sixths, and it can equal 5 pi sixths. So these are the four values when we take the sine of them that produce a value of 1/2. All four of these will, and they're between negative 2 pi, which is right over here, and 2 pi, which is a little further away. So those are the u values we're looking for. Now, if we look at the original equation, we're not asked to find what u is, we're asked to find what sine is. So we're going to go back and resubstitute and say, well, I know what u is, and I want to find x from here. This equation that we built at the beginning allows us to find the x values. So I can just go through, u is equal to x plus pi sixths, and I can solve each of these. So for the first equation, negative 11 pi sixths is equal to the x value we want plus pi sixths. So to solve for x, we subtract pi sixths, subtract pi sixths, and we have 11 pi sixths, take away one more pi sixths, so we have negative 12 pi sixths, or negative 2 pi, as our x value. Now we just go through and do this same process 3 more times. So our u value, negative 7 pi sixths, is equal to the x value we want plus pi sixths. So subtract pi sixths, subtract pi sixths, and we have negative 8 pi sixths as our x value, or that would be negative 4 pi over 3 as an x value. Now for pi sixths, well, pi sixths is equal to the x value we want plus pi sixths, subtract pi sixths. It's always going to be the same operation because we're using the same equation here. So 0 is another x value we're interested in. And finally, 5 pi sixths is equal to the x value we want plus pi sixths, subtract pi sixths, subtract pi sixths. So we have to undo that substitution step, and we would have negative. Oh, actually, this is going to be a positive. I was getting ahead of myself. 5 minus 1 is 4 pi sixths there. So 4 pi sixths is the x value, or 2 pi over 3. So these four values that we just stated for x, when we substitute them back into the original equation and take the sign, or add pi sixths in first, then take the sign, they'll produce 1/2. And these values are all between negative 2 pi and positive 2 pi. One of them is negative 2 pi, but we're okay because we're including that value. So if we just go through, and we can write these all out at once, the x values that satisfy this equation are negative 2 pi, negative 4 pi over 3, 0, and 2 pi over 3. So there we have it. Substitution, or use substitution to solve trig equations all the way through. I hope this video and sequence of videos helped you. Make sure you're commenting, asking questions in Google Classroom as your questions arise, or communicating with your teachers with those questions that are coming up. We'll see you in future videos.